All right, welcome back. Hopefully you worked on the assignment that I left you with in the previous lesson. Very important for you to be getting that practice. And now we're going to go over the solution to this problem. So we're creating a dealership and we have customers, we have employees, and this is a car dealership. So we of course have vehicles. So there are 4 nouns. You're going to need 4 classes. We already have the dealership class, and I already pretty much almost completed the customer class in the previous lesson. We of course need to complete this purchase car method. All right, going back into the dealership class, this is the main method. This is where the main method resides, and everything in here line by line is going to be executed. So this is the magic method where the customer that we've instantiated here, we're giving it some values such as his name is Tom, his address, and the amount of money that he has on hand. Once we instantiate the customer here and then we give him these values, this object variable, we can invoke the purchase car on this object variable. And we pass in the vehicle that he's interested in and the employee that he chooses to get help from. So of course these 2 objects have not been instantiated yet. Not only have they not been instantiated, we haven't created their classes either. So let's create the vehicle class first. I'm going to right click here, go to new, click on class, and type in vehicle. Okay. Of course, keep in mind the naming convention here. All classes should be with a capital first letter. And we of course don't need the main method. We're going to leave that without the main method. We only have one starting point for our application, and that's the dealership class. So let's go back to the customer class and notice the purchase car method takes in the vehicle, the employee, and whether the customer decides to finance the vehicle or not. So this first argument was erroring out before. There was a red squiggly line. That's no longer there because we've created the vehicle class. Now let's create the employee class. You can just hover your mouse here and notice that it says the employee cannot be resolved to a type, and there are a couple of fixes. Let's just select the first fix right here, create class employee, and that's another way to create a class that you need in your program. So now if we go back to customer and look at the purchase car method, it's compiling now. There's no errors in this class. We of course need to populate this method, but this class is compiling. It's a valid Java code. Same thing goes for the vehicle class. It's a valid Java code, and the employee class, and we're going to fill these out pretty soon. Let's go back into the dealership and notice that we need to instantiate the vehicle as well as the employee. So let's do that. We'll call it vehicle equals new vehicle. And now that red squiggly line is gone. Let's do the same for employee. And now that red squiggly line is gone for this emp variable and this vehicle variable. And here's just some junk that I was trying out before I started the video. Let me just get rid of that. So now all of the code is compiling. It doesn't do anything. If I hit the run button, nothing is going to get printed out here. The general idea was that we had to create the handle customer method in the employee class and invoke that handle customer method in the purchase car method of the customer class, all right, on the particular employee. So let's first implement this handle customer method in the employee class. So employees can have other attributes such as their age, their salary, what department they work for, their name of course, but I'm not going to get into any of that. I'm just going to define the method, which was handle customer. And the first argument to this is going to be customer, CUST is going to be the variable or the parameter name. The second argument was Boolean finance, whether we want to finance the vehicle or not. And then the final parameter is going to be the vehicle that the customer is interested in. And one obvious mistake here is I'm misspelling the word handle. So let's just put LE here. So this is the method signature. So back in the customer class, the customer purchases a car, right? And what he needs to do is he needs to elect a particular employee, and that's going to be this variable right here. So we can invoke the handle customer method on the employee. So we can just do emp dot handle customer, and we pass in a special keyword that we looked at a little while ago in object orientation section called this. This means whatever instance of this customer class, whatever customer, that's what this variable is going to represent. Okay, this keyword, this. We've seen this already. And there's going to be a true or false value that goes into this finance parameter, and then the vehicle that the customer is interested in. All right. So this class, I don't expect this class to change after this. That's all you need for this purchase car method. So most of the work now needs to be done in the employee class. So looking back at the dealership, take a look at the instructions that we need. So if the finance argument is passed in as true, then we're going to run a credit history. Else, if the vehicle's price is less than or equal to the cash on hand, then of course that means that the customer is capable of affording the vehicle. So we could just process the transaction in cash. Otherwise, if both of these don't qualify, then we have to tell the customer to bring more money. All right. So let's go to the employee class and implement this behavior. So the first thing is we're going to check for if finance is true. So if it is, then we're going to figure out the loan amount. So that's going to be a variable called loan amount. And we're going to assign this the difference between the vehicle's price and the amount of money that the customer has on hand. Okay, so this method we've already defined in the customer class. We have yet to define this get price method on the vehicle class. Let's go back to the vehicle and notice that we don't have anything in here. So let's give it some attributes. Some of the attributes that we need, of course, is the make. So we're going to define a variable called make, and then we can have another variable called model. And just one more thing, we're going to, of course, need the price of the car. So going back into the employee, we have two options. We can either do dot price, all right, or we can invoke the get price method, which is a better option, right? This is a better way to encapsulate the data. So I'm going to create getters and setters for these variables. All you have to do again is right click here, go to source, and then click on generate getters and setters. Select all of them and hit OK. And now we can make these variables private. So no one will be able to access these variables directly outside of this class. And if anyone needs to make changes to an instance of vehicle, they'll have to use these methods such as set model and make and set price. And we can get that data by invoking the get versions of those methods. Okay, so now going back to the employee, this code is also compiling. So the difference between the vehicle price and the cash on hand, that's going to be the loan amount. If finance was passed in as true, we can run credit history by passing in the customer and passing in the loan amount. Now, of course, we still have to define this method, and we could just define this method right in this class. So outside of the handle customer method, I'm going to define this run credit history. So we could do public void. It doesn't return anything. We'll just have it print out some information. And the arguments that it takes is it's going to take the actual customer that we want to run the credit history on. And the parameter here is just cust. You can name it anything you want. And the loan amount, that's going to be of type double. Again, these variables, these are parameters, you can name them anything you want. So whatever data gets passed into the invocation of this method, whatever data gets passed into these will be assigned to these variables, all right? So if I pass in the number 99, this number is going to be assigned to this variable inside of the body of this method, okay? So let me move that back to loan amount, because the loan amount is being computed up here, and that's going to vary depending on the vehicle's price and the cash that the customer has on hand. So we pass that data to run credit history, and what is run credit history going to do? Well, it's just going to print out to the screen that it ran credit history for customer, and I'll make it print out one more thing. We can say, we'll make this a very generous bank, and we'll just say customer has been approved to purchase the vehicle. All right, so now this code is compiling. There's no more errors. Now what happens in the case that finance was passed in as false? We can have an else if statement here, and that's going to check for whether the vehicle, if its price is less than or equal to the cash on hand by the customer, cust.get cash on hand. If the vehicle's price is less than get cash on hand, we can just have a cash transaction. Customer pays in cash. As a matter of fact, going back into the dealership class, the instructions down here, I have this method called process transaction. So let me just copy the definition here, and we're going to define it just like we did run credit history. We're going to define that method here too. So it's going to be public void process transaction, and this can just print out the fact that the customer has purchased a vehicle in cash. So you could say customer has purchased the vehicle, and then we can use a plus sign, and then we give the actual vehicle that they purchased, and then we need another plus sign, and I can put for the price, and I can have another plus sign out here, and we can say vehicle dot get price. Whoops, not get make, get price. Let me move this on another line like that, and then we can invoke this method in this else if section. So we can say process transaction and pass in the customer as well as the vehicle that they purchased. So otherwise, if finance is not true, then it would go here. Otherwise, if the price of the vehicle is more than the amount of money that the customer has on hand, and they did not want to finance anything, in that case, we're just going to have an else clause, and we could just print out that customer will need more money to purchase vehicle. And I can put the vehicle out here with a plus sign. Okay, we're going to just append whatever vehicle at the end of this sentence. So there you go. That's pretty much it. We finished the vehicle class. We don't need any special methods here besides the getters and setters and the attributes. That's all we need for the vehicle class. So let me close that. And the customer, we don't need anything else. We just need the cash on hand. We've already defined that. And then the name. And then we have this special method. This is the guy that triggers everything. Once this purchase car method is invoked on this instance of this class, right, of a customer, when this method is invoked on an instance of customer, this information will be passed in, the particular vehicle of interest, the employee that the customer wants to deal with, and whether they want to finance or not. And we just pass that over to the employee's handle customer method. Okay, so this is wired in already. We don't have to change anything about this. So let's go to the dealership class. We have a vehicle and we have an employee. Now, of course, the vehicle, we need to give it a price. So right now, if I hit run, notice that it says the customer has purchased the vehicle, and this is the horrendous name that the default object gets by the Java language. And we're going to get into how we can change this displayed object in a little bit. But notice that the price is 0, right? The reason for that is because we have an instance of vehicle, but we haven't given it any data. So after the vehicle object is instantiated, we can assign it by using the setters. So we can say set make is going to be Honda. We can do set model is going to be Accord, and you can obviously use any values that you can come up with. And we need to set the price, which is the most important because we have logic surrounding the price that the vehicle is for. So let's say that the vehicle is for $10,000. Okay, that's the price of the vehicle. The cash that the customer has on hand is $12,000. So the way we have this currently set up, take a guess as to what's going to be printed when I run this method. Let's hit play. And notice that it says customer has purchased the vehicle. This is the vehicle for the price of $10,000. Okay, and this got printed because we're passing in a false for the financing option, right? Going back into the customer class, when we invoke this handle customer, we pass in the finance value, that whether it's a true or false. And since we're passing in a false, in this method, it's going to jump down to this code right here. Since the cash that the customer has on hand is greater than the price of the vehicle, we could just process this transaction and the customer walks out of the showroom with their car. Going back here, if I change this, instead of 10,000, the vehicle's price is 15,000, and we hit play, notice it says customer will need more money to purchase this vehicle. All right. But if we change this false value to true, then it's going to allow financing. The customer will be able to finance the vehicle. So hit play and notice it says ran credit history for customer. Customer has been approved to purchase the vehicle. All right. So I wanted you to get this exercise thinking about how to make objects interact with each other. So again, these are variables. This cust1 is a variable of type customer. All right. And this is a reference variable. It points to the actual object that sits in the heap. And we can change the data that that object contains by invoking these setters and getters on this variable. All right. Same thing goes with the vehicle instance. And the employee, we didn't give it any other data because, we just want to make sure that the employee class has this method handle customer and the rest of the things that it needs. We didn't care about the attributes of the employee. Now, another thing I want to point out is, let's go back to the dealership and notice that the vehicle, we're having to, once we instantiate the object, we're having to set its make, the model, and the price. We can do these things at birth. When the actual object gets instantiated, we can give it the data that it needs. So let's go to the vehicle class. And we can define a constructor for these attributes. So right click here and go to source. You've seen this before. Instead of generate getters and setters, we can generate the constructor using fields. All right, and just select all of these three variables and hit OK. And now it gives the ability for the developer to be able to invoke this constructor and passing in the data, so that instead of using these setters, we can just pass in the data that we need. So the first argument is going to be Honda, the second argument is going to be Accord, and the third argument is going to be the price of the vehicle, like that. And we can get rid of these methods here. So as soon as this line gets invoked, an instance of the vehicle gets instantiated with this data, and the variable is assigned the location for where that object is in memory. All right, and then we can pass this vehicle over into this, and everything else will work as expected. So same thing goes with customer. I can also go into the customer class and create a constructor for this instead of having these setters, but I'll leave that to you to try out on your own. We have to move on to one very important thing. Let me change this to 25,000. Since the vehicle price is 15, I just want to show you something with 25. That's too many zeros there. And I don't want to finance this. I'm about to show you something regarding the way the vehicle object gets printed. So let's hit play and notice it says customer has purchased the vehicle, and this is the vehicle for the given price. Now this is not a very useful representation of the vehicle object. And the reason is because going back to the employee class and taking a look at the process transaction method, this prints the vehicle passed in. And this variable has this value right here. And that's not a very useful value. And the reason for that is we need to define a special method in the vehicle class so that when it gets printed, the output is more reader friendly. All right, so let's go back to the vehicle class for a second, and I'm going to define a method called toString. As a matter of fact, let me show you a shortcut. You could right click here, go to source, and select generate toString. Click on that, and notice that it will have these three values as part of the method. So hit OK, and there you go. It prints the class's name, vehicle, and then it gives the data, the make, the model, the price, as part of the output. Okay, so now back in the dealership, when I hit run, it's going to print a much more reader friendly format. So let's hit play and notice this is a lot more reader friendly. We have the vehicle class, the make is Honda, the model is Accord, and the price is this. So the reason why it printed gibberish before was because, well, let's take a look at the vehicle class. Every class inherits from the object class. All right. So the object class, press the control key and click on this method right here, toString, and select open super implementation. This is going to take us into the object class, okay? And you're going to see the toString implementation. And notice that the default that gets printed for the object is the class name, and then this @ sign, and then there's some random hash code. That's the gibberish you were seeing at the end. Let me just quickly remind you, back in the vehicle class, if I comment this code and hit run, this is what gets printed out. This gibberish at the end, this is the hash code that gets printed as part of this toString method. All classes inherit from this object class, and the vehicle is no exception. This is also inheriting from the object class. So when we do a dot on any of these objects, the vehicle or the employee or the customer, we get all of these other methods that we haven't defined. We get the hash code, the toString, notify. All of these methods are actually in the object class, and since all classes inherit from the object class, all instances of those classes have the ability to invoke the same methods as the object class. All right, review the inheritance lesson that we spoke about a couple of lessons ago if you're having trouble understanding this. But all classes inherit from object. I know it doesn't say extend here after any of these classes. That's because it's done by default, okay? So instead of relying on this toString method, we can override this method in the child class of vehicle by just putting something like this. And this is a much neater way of printing the data as opposed to something like what you see down here. All right. And another crucial thing is the equals method. Let me get rid of this dot here. If I define another vehicle, let's create an instance of vehicle. I'll call it car is equal to new vehicle. And we're going to give it, this is going to be a BMW. The model is going to be M3. And price is, let's say, 20,000. Here's a variable of type vehicle, and we have another variable of type vehicle that's called vehicle. If I give the same exact data that's in here to this instance, now the data that this variable is pointing to is exactly the same. We have two vehicles of the same exact criteria. When we compare these vehicles, we want to make sure that we use the equals method. Not the equal sign, the equal method. And I showed you this in the string lesson. To compare strings, you don't want to use equal equal, you want to use the equals method. So we could do car dot equals, and then we pass in the vehicle. And this will return a Boolean value, whether both of these are equal or not. And I'll just define a variable here. We'll call it value. So this will have the data whether both of these vehicles are equal to each other. And let's print out what this is going to contain. Let's hit play. And notice that it's saying false. So where did this dot equals come from? Press Control and click equals, and notice we're back in the object class. And this is the method that basically takes one object and compares it with the other. All right. And we're not supposed to be using equal equal to compare instances. So what we need to do is go over to the vehicle class and override the equal method. Just like we're overriding the string method, we need to override the equal method. So you can right click and select source and click on this right here, generate hash code and equals. And it's going to select all three of these variables, and notice it comes up with all of this fancy code for you. And then it checks for whether the class, this instance's class, is the same as the instance that was passed in. It compares that class, and if it's not true, then it returns false. Then it takes that object, converts it into a vehicle by casting So it takes that object and considers it a vehicle and then assigns that to this other variable here. It's comparing the actual values of the fields, such as make. Is the make the same between the two vehicles? Is the model the same between the two vehicles? Is the price of the two vehicles the same? And if all of this is true, if all of these are the same, only then it returns true. Otherwise, it would return false. Going back to this dealership class, we were comparing the data in the car variable with the data in the vehicle variable, right? Not the backend memory locations or hash codes or anything like that. We're actually comparing the data, such as BMW M3 20,000 and the vehicle's data, BMW M3 20,000. We're comparing the actual data, and now instead of false, it should return true. So hit play and notice that now it's printing true. So it's a really good idea to implement the equals method on your objects as well as this toString. All right, and that's what we're doing in this vehicle. We implemented this equals method as well as the toString, and notice that both of these are being overridden. Okay, so again, what was override? This will take the place of the method in the parent class. So since all classes are children of the object class, right? All classes inherit from the object. When we introduce our own toString method, we are overriding the default object class's implementation of override, and we have this more friendly looking output. And same thing goes for here. Instead of the equal sign of the object class, we have our own overridden version in this class, and it's going to actually return true or false based on the actual data of the argument that's passed in here and the instance in which this equals belongs. Okay, so this equals method is being invoked on this car. So we're comparing the data of car with the data of this object that was passed in here, and if the data is the same, this is going to return true, and that's what's being printed out here. All right, so we covered a lot of ground in this lesson, so take your time to internalize all of these details, and I hope that you tried to solve this problem on your own, but I really wanted to get you working with multiple classes. And this is just the beginning. We're going to get even more practical in the later lessons when we talk about reading and writing files, and we're going to get into a lot more Java specific details such as generics and collections. So stay tuned. I'll see you soon.